Hi, we're going to do a review today. I'm going to use the preparing for assessment page, which is on page 455 in your book, and go over these multiple choice questions as a way to help you prepare for the upcoming test for this chapter. We still have a few lessons to go over before we take the test, but I think right now is a good time to do some review and just to make sure that we are all on the same page with this type of question, which is exponential growth and decay. Okay, so I'm going to go over these questions one by one. All you have to do is watch them with me and make sure you understand everything. This is just a video to help you review for what we've been covering. Okay, so number 35. A small town currently has a population of 15,000. Each year, the population decreases by 2.25%. What will the population be in 8 years? Okay, so the key word here is decreasing. So this is a question of exponential decay. When we have a question of exponential decay or decrease, we use this formula where R is the rate of decrease. 2.25% is written as 0.0225. Okay, make sure that this place, okay, in the hundredth place is the ones place, if you will, of your percentage. Okay, so what you want to do is put it into this formula. Y is equal to, A is always the starting point, the initial amount, and then multiply by 1, minus, because we are decreasing, and here is your rate of decrease, and then the x is always the number of times that it is decreasing. So if it's an annual rate of 2.25%, okay, each year means every year. This is an annual rate after 8 years, so 8 will be your x. Okay. After you calculate this, you can use your you write this out. You use your calculator to take this base, raise it to the 8th power, and then multiply that answer by this number to get your answer. Okay, so for this question, it will be around, this is the correct answer. Okay, if you don't have a calculator, okay, you can still do an estimate. You can make a good guess. You know it's not going to be this one, because this is higher than the original amount. These two are too close to the original amount. If you do an estimate, 2%. 1% of this is 150. 2% will be 300. 2.25% is around 340. Okay, so around 340. So each year it's decreasing by that. So if each year is decreasing by 340, then you would not probably have these two numbers. Now, of course, the amount of decrease is going to go down because the population is going down. So 2.25 of a smaller amount is going to be less than the amount that was decreased the first year, right? So each year it will still go down, but by a smaller number. Still, this will be the answer that makes the most sense. Okay, number 2, the next one. Robert invested this much money in an account that pays 4.5% interest rate, compounded weekly. Weekly, so when you see that word, you know that you have to multiply your number of years by 52. Okay, 52 years, multiply the number of years. Okay, so after 3 years, what's the balance of the account? So for this question, you also need to do an estimate, basically. If you don't have a calculator, even if you did, you could do this without it. Basically, this much increasing by this much, interest compounded weekly. This interest rate is always going to be an annual percentage rate, not the weekly rate. Okay, so make sure you don't mistake that it's increasing by this much every single week. Okay, so your final amount after 3 years is probably going to be around this. Okay, these two are way too high. Okay, so this is probably the right answer. Next question. The value m of a baseball card is given by the equation m is equal to 240 times 1.25 times t to the t power, where t is the number of years after 2012. What is the value of the card m in dollars in the year 2012? This is interesting because t is the number of years after 2012. So what is the value of the card in dollars in the year 2012? So the year is still the same. So what it's really saying is what is the value of the card right now, okay, if no time has passed. Well, we know the initial amount is just this number, the number that's in the position of A in your equation. All of these equations have this form. This is always the initial amount. So whatever is here, okay, 240. If it's 1.25, that means it's increasing by 25% every year. Okay, let's see this one. Which exponential function passes through 0, 2, and 2, 12.5? This question actually does not require you to calculate. It's a question of understanding what these things mean. When you have the y-intercept, like here, okay, the y is really your a. The y is your a. So you know that your a has to be 2. So that eliminates this answer. Then you're going to look for the rate of increase here. Okay. If the rate of increase is 12.5, okay, then after 2 rounds, it would not be 12.5 anymore, right? So if you to go from 0 to 2, that means it has increased 2 times. This would not be the correct rate. Okay, so it's not this one. Okay, so it's this one or that one. Okay, so if you were to calculate what b is, so that's what we're trying to figure out. What is the b? Well, if y is equal to 2 times b to the x, okay, and y is 12.5, then an x is 2, okay, and we get those numbers from here. This is your x, this is your y. So this is your y is 12.5, here's your x. Basically, you divide both sides by 2, you get 6.25 is equal to b squared. Take the square root, b is equal to 2.5. Okay, so that solves this question. This is your answer. Number 39. The population of a small town in thousands can be represented by y equals 2.6. Okay, when it says in thousands, okay, that means this number is actually 2,600. That's what 2.6 thousand means. Where t is the number of years since 2010. Okay, so we can see that this population starts here and it's increasing because it's over 1. Increasing at a rate of 2%. That's what this 1.02 means. Okay, 2%. Based on this model, which statement is true? So I've already figured out like what the numbers mean. Initial amount of 2,600 people growing at a rate of 2%. So let's just see which one matches. The population in this year at the beginning was this much. Correct. So this is one of the answers. The population of a town is increasing. Yes, that is true because this is a number that's over 1. The population increases by 20% each year. We already said that this is increasing by 2%, so this is not correct. The population in 2020 will be greater than 3,100. Okay, so that's saying like in 10 years, it'll have grown by like about 500 people. We're not sure, but I don't think it's going to grow by that much because it's only growing by 2%. Okay, if it grows by 2%, even in 10 years, I don't think it will grow to this much. But we will see. That's a maybe. Let's see. The population in 2015 was about this much. So that's only 5 years later. 5 years later, do you think it could grow by 900 people? I don't think so. Okay, so this is no. Okay, because it's only growing by 2% every year. And then in 1 year, basically, in 1 year, the population increased by 102%. Of course, that is not true. It's only growing by 2%. Okay. So the only thing we need to calculate to find out is if this one is true. Okay, so basically, is this true? Will it be 3,100? Okay, using this formula. Okay, 2020 is 10 years later. So you're just going to find out if this is true. Okay, if this is true, or if they say will be greater than. So is it greater than? If this statement is true, then D is true. If you calculate this and this is not greater than 3,100, then this is not true. Okay. Let's see this question. Gina just purchased an antique desk worth $8,000. The equation V equals 8,000 times 1.03 to the T models the value of the desk after T years. Which of the following best describes the meaning of 1.03 in the equation? Okay. The value of the desk will decrease by 1.03% each year? No. Okay, this thing is clearly over 1. When the B is over 1, this is one of these situations. So this is 1 plus 0.03. I'm sorry, 0.03. Okay. The percentage of increase is actually 3%. Okay, so this is wrong. The value of the desk will increase by 1.03% each year. That's also incorrect because it's growing at 3%. The value of the desk will increase by 3% each year. This is correct. Okay, and this one is clearly wrong because it says decrease. Number 41. Which exponential function represents the graph shown? In this graph, you can also see the y-intercept. When you have the y-intercept, this number is the a. So we know that in the equation, the a has to be 3. So that eliminates both of these. We're going to choose between these two. This one has a rate that's less than 1. So this is an exponential decay function. This one is greater than 1, so this is an exponential growth function, and the decay function is the one that matches the shape of this graph. So this is the answer. Okay. Miguel filled the ball with 1.6 pounds of air. Every 2 months, the ball loses half its air. Which equation represents the pounds of air represented by P that remains in the ball after 9 months? Here it says that every 2 months, the ball will lose half its air. So if you have 9 months of time passing, this exponent cannot be 9. It has to be 9 divided by 2, okay? Because it's going to change the rate that they gave you is for every 2 months. So we already know that this one is not, and this one is not the answer. We're going to choose between these two. And since it's a question about a ball losing its air, it has to be an exponential decay question. So between these two, we choose this one because it's a decay question. The 0.5 will give you that decay. Okay, so that's how you determine the exponent in the equation. I already explained. Okay, this amount of time has to be divided by the period that they gave you. Okay. So 9 over 2, okay, will be 4.5. Okay, you're only going to calculate this like every for 4.5 times. And then explain how you determine the base of the exponential expression in the equation. And I explained the base right here. The B is either a decay question or a growth question. And this question is clearly a decay question, so this is your answer. Okay, so those are the tricks for answering this type of question. I hope that helps you. We will be having a test sometime next week on this lesson and some of the previous lessons. We're going to be doing a review as well for the first 5 lessons in this chapter. Okay, I will talk to you guys next week. We will not have any homework for today. I'm going to assign a few worksheets to you, but they are not required. They're just for you to do if you want to do them. Okay, so they're optional.